Hello everyone and welcome to this video on Diode Logic. So in this video I will be discussing on the different logic families, say logic gates using of Diode Logic. Basically I will go for OR gate and AND gate, how to realize an OR gate and AND gate using of this Diode Logic. This is a series of lectures under the course of digital design. This is the self-learning topic number 3. How the diode logic will work it out. So the name over here itself defines the logic family, as it is comprises of only the diodes. So the meaning diode logic, what it does is that it makes use of the diode, and that the switching electronic switch activity of the diode is being used to conduct an electric current from not to conduct the electric current. It switch from 0 to high and high to low. How it moves and how it works we will be showing with this one. Before going to that one, first we will have a look at about the PN junction diode. This is very important part of the is very important. Already you have studied the PN junction thoroughly in your analog circuits. Just once we go ahead with this definition over here. So when you go for an PN junction diode, when you are going for the forward biasing and PN junction diode, in forward bias, what we do is that the N-type region, N region is been connected to the negative positive, and plus region, let's say P-type region, P region is been connected to the positive end of the positive. So here again, once again, it has been shown over here. This is your negative end, and this is the positive end. So what happens when you are having positive end is been connected and when negative end is been connected? So here what happens is that the depletion region will become thin and thin and thin. Why? The positive ions are repelling the photons over the P region, and the ions moves away and the region becomes thin and thin one after the other. And the current conduction would be taken into consideration. And there would be a drop across the voltage drop there. It is conducting it have any conduction voltage of 0.7. Similarly, the circuit symbol for this one is been shown over here. You will be having one transistor whose current is called as the diode current. So there is a diode over here, and whose current is given the diode current. And on the right side, you can see this is the conventional current flow diagram, and right side you can see the um, graph for RC characteristics. The graph for the PN junction diode. This has been shown on to the right side. Now coming to the diode OR logic. How a OR logic is been implemented in diode. How OR logic is been implemented. You can see there is an when you go for once again go back over here. So this is your negative N and this is your positive N. Remember this term very well. So positive N and negative N. And the same thing over here we can apply it. This is your uh, positive N and this is your negative N. So when you apply 0 over here, what happens? When you apply 0 over here, what happens? So when you are applying 0 at one of the terminals or on both the terminals, then that particular diode, this has been given 0 to this one, and you would be having positive voltage over here. So then this diode is been so if you connect and here very good assumption is being taken into consideration. We are taking 5 volts as a logic 1 and 0 volts as the ground voltage or 0 volts. So if both the inputs are unconnected or it is been given to logic 0, the output will also be held at 0 volts. Why? Because both of the diodes have been conducting. There is a path over here that and it would be there. So this would be the case when both the both the inputs are 0. If one of the input is raised to 5, one of the input is raised to 5, or both the inputs are raised to 5, it is a logic 1. Then both this one becomes a forward bias. So positive end is been connected to the positive end and negative end is been connected to the negative end. And here this logic and the output would be equal to the high voltage. It would be connecting and you would be having become forward bias and there would be a, therefore this will be connected. And the output will be at logic 1. So this gate, when one of the input or both the inputs are high, the output is giving it as a logic 1. So this is a OR function. Similarly, in the when we are taking an mm, uh, AND gate configuration in diode logic, we'll keep the transistors connected in opposite direction, just like your how you have connected a diodes in your OR logic. It is quite opposite to this one. And same thing, one more resistance is being taken into consideration called as pull-up resistance. The top one must, I remember, you should remember that the top resistance is a pull-up, and the bottom resistance given to the circuit is nothing but pull-down, pull-up resistance and pull-down resistance. So here the same thing happens over here when you are making one of the input as low or both the inputs are left. The same thing is being taken into consideration. High voltage given as 5 volts and low voltage given as ground or it is left open. But usually we doesn't prefer to get it left open because when we left open the currents will unwanted noises may be occurred into the soil. If both the inputs are unconnected or if both the inputs are large, but output would be at logic 1. So mean to say, when you apply 5 volts, when you are applying 5 volts, at that moment it is both are conducting and you will be having voltage which is equal to VC. So here, if one of the input is grounded or the diode is conducting, and put the output down to 0 as well. So here both the inputs must be logic 1 in order to get the output as what? Logic 1. So this would be the case of what? AND gate. Okay. So this is the case of what? AND gate. So in the previous circuit would be representing the OR gate circuit and this is one AND gate circuit. So this logic where we are using only the diodes to represent this to separate to get the gates of required gates, then that type of logic family is called as diode logic family. Okay. So any more doubts are there, you can clarify it at my visiting to my cabin. Thank you everyone.